So we are starting our fourth theorem, and this theorem, we are going to look at what we call a cyclic quadrilateral. Can you let me know in the chat when someone talks about quadrilateral, what comes to your mind when someone mentions quadrilateral? You can type in the chat, or someone can raise up the hand and you tell us when someone talks about quadrilateral. Okay, yes, Apple?
Quadrilateral is a four-shaded figure.
Okay, very good. So when they talk about a quadrilateral, it means a four-sided thing. So when we talk about now cyclic quadrilateral, that's what we are going to focus on. So when they talk about cyclic quadrilateral, like we have said, quadrilateral means four-sided figure. Now, when we talk about cyclic, here what has to come into your mind that we are going to deal with something circular. So here we are going to look at a four-sided figure that is within a circle. So that is the property we are going to be dealing with. A four-sided figure inside a circle. And whenever we talk about a cyclic quadrilateral theorem, one thing that you need to know is that that figure that we are going to form, that I'm going to have a figure and I'm going to have a four-sided figure. And this four-sided figure is formed by the different chords. So it can be something. This is one chord, this is another chord, this is another chord, and this is another chord. So when you look at what I have, this figure or this polygon has the four sides. This is 1, 2, 3, 4. And number 2, that this figure I have is formed inside a circle, that it is inside a circle. So one other thing you need to know that the vertices or the corners of that figure that is being formed must be able to touch the circumference of the circle, or should be able to touch those parts of the circle. So that is the theorem that we are going to look at. And always when it forms, we say that whenever you have two chords meeting, they will be forming an angle. So they will be subtending an angle. They will be forming an angle, and they are going to be forming an angle. So this is the theorem we are going to look at in today's lesson. So that activity will verify it. Allow me to go into the theorem. Now, what does the theorem tells us? The theorem will tell us that whenever you have a cyclic figure, quadrilateral, opposite the angles facing each other. For this, I have these angles here. These angles that are facing each other, they have something special. I don't know whether that's what Carl wants to tell us. Yes, Carl? Carl? Okay. Now, these angles that are facing each other, they always add up to 180. So mean that angle D plus angle B, I'll end up with 180 degrees. Similarly, these angles here are also facing each other. So it means that also angle A plus angle C, I'll end up with 180 degrees. So that is the property. But also, whenever you have a quadrilateral or any four-sided figure in math, when you add all the angles you have inside, these angles must equal to 360 degrees. So when I add what I have as my angle A, angle B, angle C, plus angle D, the answer I get must be equal to 360 degrees. So that is the property. Kindly let's write as I respond to Carol. Carol? Angel? Okay. Okay.
What is
Yes?
subtending?
I beg your pardon? I'm not getting you well.
I didn't get
You did not?
subtending.
Oh, like we said, subtended. Subtended, it means uh, which word can I use? Subtended means that an angle that is formed between two lines. That when you have two lines, I have this line and I have this line meeting. The angle that those lines are forming is what we call a subtended angle. So when you look here, I have, this is my chord. This one is also my chord. So the angle formed here is what we can call the subtended angle. But for that particular one now, it will be formed by this arc here. So the word subtended, like I told you yesterday, comes from the Latin word sub means under, tendere means to extend. So the any angle between two lines at a point is what we call a subtended angle. And always those angles are formed at the circumference. Whenever you hear a word subtended in circles, it means that those angles are formed at the circumference. Okay, people have finished. We can give 2 minutes. Uh, okay. Okay, thank you, Patricia. Yes, an angle within a circle that is created by two chords at a point on the circumference. Okay, I think we are good to try out now a number. Yeah, can everyone try out this? Ninety-five, 95, 95. Good, good. Yeah. 95, 95. Okay, someone to take us through quickly. Yes, Massa.
Good morning, everyone.
Good morning.
So, since the angle opposite 85, the angle x plus 85 is equals to 180. So 85 minus 85 plus x is equals to 180 minus 85, which is going to give us 95.
Okay. Thank you. So that's how we do that. Okay, we are going to move on to another number. Okay, we have another number here. So we are trying out. Okay, seems people have already got the answers. Okay, can we have someone who is going to be taking us through? Okay, Jonah and Patricia.
Good morning.
Morning.
Okay, I'm going to do for X. Right? Since angles are in a cyclic quadrilateral which are opposite equal to 180, so it will be X plus 94 equals to 180. X plus 94 minus 94 equals to 180 minus 94. And our X is 86.
Okay. Thank you, Patricia. Yes, Jonah.
Good morning.
Morning.
For what? Under the cyclic quadrilateral, we have a property that states that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Therefore, from the figure above, angle Y is equal to 118 degrees. Because
Okay.
110 degrees is an exterior angle and is equal to Y, the interior opposite angle. Yeah, that is it.
Okay. How does it come? That's what we want.
For me, I was just like giving that reason and
Oh,
saying, yeah,
okay. Okay. Thank you, Jonah. It is correct. But now I want how it comes about. Yes, Trevor?
Thank you, morning. So it comes in the way that since we are dealing with angles of maybe we shall make an unknown here called 118 equating to, shall get 118, which will give us 62.
Okay.
So
So
after
here.
getting the 62, it's 62.
Okay.
Yeah. So then we shall say y plus 62 equals to 180. Then we shall say y equals to 180 minus, which will give us 118. Thank you. 118.
Thank you. Yes. Okay. Now, you need to, here, one of the things that I wanted people to notice that, like they have already told us that whenever we have an interior angle, this is an interior angle, that always this interior angle is equal to the angle that is exterior to its opposite. That if this is 118, it's going to be equal to the angle you'll have here. That one interior angle is equal to one exterior angle, but they must be on the opposite side here. Take an example, even the same thing will happen here. That the angle, this is an exterior angle, and this is an interior angle. So the angle I have here as my interior angle will equal to the external angle I'll have at this point. So that one is also a property. But you need to be a bit careful is that whenever here, they may not just want you to state something. If there is a way you can do it to prove it, always better you follow the, let me say, the working on how it comes about, other than you just stating it. So always it is a good practice to show how something comes about if there is, if you can, other than just stating it there and then. Yeah, so the best approach should have been you working out and showing how it comes about. Okay. Olive, do you have a question?
No, I wanted just to give the answer of that angle.
Oh, okay. Okay.
Yeah.
Okay. 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 We are now going to try out. We are trying out all the numbers. This is our A. This is B. This is C. And this is D. So we try out okay, I think let me call them Roman. This is Roman 1. This is Roman 2, Roman 3, and Roman 4. So let's try out all those Romans. Okay, I'm looking through the chat. Number 1, people are getting 65 and 80, and that is good. Guess that's what you are getting. You're on track. Chris. Okay, I'm saying answers are coming through in the chat. And we shall only do one number that people will choose that they want to do. Yeah. Yeah. So as we are working out, I want to also bring it to your attention that you can as well find out that there are numbers we are going to be approaching that will require us to apply all the theorems we have so far looked at. So whenever you find some numbers, you need now to know that you may find yourself that you need to apply as many theorems as possible. So don't think that it will only be one theorem, no, you'll find that at times you may need now to apply very many theorems. So that one, do not forget. Okay, is there any number that you feel we need to go through here? Any number? You can let me know through the chat. Any number? You feel okay? People are saying no. Okay. Roman 4 and Roman 3. Roman 4. Okay. I think people are saying Roman 4. Yeah. Roman 4. Okay. Now, when you look at Roman 4, the only thing now you need to know is to observe what is the opposite. So when you look at Roman 4, you can easily tell, or it depends on the observation or how you are really observing it, where your angles can be. But for Roman 4, the angle that is opposite to what we have, this 133 will be opposite to that. Then this 142 will be opposite to that. In other words, 42 can't be and x can't be opposite because they are lying on the same line. So things that are lying on the same line can't be opposite to each other. So that's what you needed to know for that particular one. But I wanted now to give you a mixture that requires you to involve some other properties at a go. So allow me to, this one I'm going to draw it here, and then you can see that at one point you may need to apply as many theorems as possible. So I have, this is my circle, and now this circle of mine is going to look like this. Then I'll come like this. I'll have this as 31. Then this is going to be my O. I'll bring this. I'll bring this. I said this is A. This is X. I bring this. I bring this. I put for this is Y and B. And I put for you C and B. So you're finding X and Y. Can we also first try it? You're finding X and Y. Someone's getting 59 and 121. Okay. Oh, okay. You can let me know through the chat whether we need to go through it together. How did you arrive at the answer? Okay. Okay, it seems we may need to do something together. Now, the first thing we need to do is that you know very well that this is our center. Now, you're going to do for me part by part, up to when we shall reach there. Now, let me break my circle, and you first do for me the first one. This is my center. From here up to here is radius. From here up to here is radius. So the first thing we are going to do is you are going to find which angle do we have at that point. Which angle do we have here? Remember, this is 31. But this side and this side being radius, you need to know about what happens to the base angles, these angles here. So can we first find this angle here? Angle at O, everyone. Those who are not yet there. O. So when you find O, the rest are going to start moving on well. All people are saying is 90. Sure? is 090, 118. Remember, it is very important, don't forget those properties, that for any isosceles triangle, these are the two sides, the base angles are always equal. So if this is 31, also this is going to be 31. So to find the angle you have here, so here we also have 31. So to find the angle here, you use the property of angles in a triangle. So here, where you have your angles in a triangle will work. So is 118 okay now to everyone? Magaz 59, Christian 59, and 62, good. So here we have 118. Now, after getting the 118 at that point, you'll come. I want us now to remember the first property we looked at. So I'm joining this to show you now the relation. We say that the angle we have at the center and the angle we have at the circumference, there is some kind of relation. That which kind of relation? It is always a half. So meaning I'll expect you to say 118 divided by 2, which will give us 59. So here, that's how people are getting the 59. Then after, now we have looked at the quadrilaterals. So you know that this one has been joined here, and this one has been joined here. So here you have y. So you can say that this, and this is a quadrilateral. So opposite angles are always equal to 108, their sum. Or alternatively, I don't know. Alternatively, if you don't use, before you go on and find this angle here. Also that property can work. But other people can say 59 plus y should give us 108. So that's how people are getting 121 degrees. Kindly. Okay, yes, Patricia.
The alternative. Okay, for me, what I did in order to find x, when I got the angle DOB, that's 118. And then, okay, I said that angle DOB is equal to twice angle DAB.
Okay.
Yes, then after that is when I calculated 118 is equal to 2 D angle DAB. Then I divided it, and that's how I got 59.
Yeah,
for X.
is also, yeah, the approach is very fine. Okay. Let me hope that is very clear to everyone. Okay, but please, that is how you can approach. Maybe let me give you one more that you can try out. Yeah, I can give you one more. Okay, let me just give you, and then you'll try them out in your free time. So here you'll find X and Y. You'll try out that number in your free time, and then we shall start from here when we meet again. So thank you so much for attending. We shall be starting from here tomorrow. We have more theorems. Even tomorrow we shall do more 2 theorems, and then we shall continue like that. Okay. Hope people have finished to write.